Today, we're diving into a pretty radical new idea, cognitive runtime engineering. What if, instead of just asking an AI for a one-off answer, you could actually build a persistent, structured mind right on top of it? A mind you could engineer, debug, and really rely on for some seriously complex thinking. Let's get into it. And this analogy from the source material just nails it. It perfectly captures the huge leap we're talking about here. See, we're not just asking an AI for one little fact. That's like building a single house. We're talking about having the complete blueprints for an entire cognitive city, a persistent, complex system that can think and reason in a really structured way. And this just lays it all out, right? A standard chat response is that single house. It's disposable, it's a one-off, its context is pretty limited, and it doesn't really have a solid shape. But a cognitive runtime? That's the planned city. It's persistent, it's structured, it's systematic, and it's all defined by a clear architecture. This is a fundamental shift in how we might work with these incredibly powerful models. All right, so here's the game plan for this explainer. First, we're going to ask if this is AI's next big evolution. Then we'll get into the nuts and bolts of what it means to build a cognitive OS. We'll also look at its secret sauce, this idea of an index for everything, before jumping into real-world applications and finally digging into a potential trillion-dollar economic shockwave. So let's kick things off with the big question. Is this AI's next evolution? Are we moving beyond that simple prompt and response world we're all used to? Because for as amazing as current AIs are, they've got a core limitation. They don't have a stable, persistent operating system that you need for truly complex, long-range jobs like deep legal analysis or modeling huge policy systems. So, if that's the problem, how do we fix it? Well, that brings us right to the core solution, the idea of building a cognitive OS. And this is the central pillar of this new field called cognitive runtime engineering. So what is cognitive runtime engineering, or CRE? The source defines it as the discipline of designing and building a custom, multi-layer cognitive operating system right on top of a base AI model. And the key word here, the real takeaway, is that this isn't just about clever prompting. It's a form of engineering. It's about building a stable, repeatable architecture. Now, what's really fascinating is how this cognitive OS is broken down. It's built in 5 distinct layers. At the very bottom, you've got the foundational engineering layer. Think of it as the basic OS and how it boots up. On top of that, you have the knowledge layer, which holds all the specialized modules for things like legal or doctrinal reasoning. Then, the expression layer figures out how the system generates structured outputs, like a report or even a whole textbook. Now, this next one is crucial, the memory and behavior layer. This ensures the system has a stable, consistent identity over time. It remembers and learns, but inside its defined structure. And then, at the very top, you've got the meta system. This is basically a self-awareness layer that lets the whole OS document and evolve itself. It's a complete self-regulating system. Okay, let's dive into this next part, an index for everything, because this is where the system gets really powerful. I mean, how do you measure abstract ideas like legal fairness or systemic risk? Well, the specific system talked about in the source, called the Awano-Quinn runtime, has a really clever solution. It uses a system of over 50 unique metrics, or indices. These are designed to evaluate everything from the fairness of a law to the hidden logic of an algorithm. It's all about turning these fuzzy, abstract concepts into quantifiable data. And this table here gives you a real taste of what we're talking about. I mean, look at the algorithmic opacity index. It measures how unexplainable a system's logic is. Or how about the youth participation burden index? It actually quantifies the fairness of a policy's impact on young people. There's even an index to measure how fast our legal systems need to adapt to new technology. This is pretty groundbreaking stuff. So that brings us right to our fourth section, real-world applications. Because this isn't just some abstract theory, right? It's about turning these powerful ideas into practical tools that can actually be used for governance. So, what can this technology actually do? Well, it can be used to analyze incredibly complex digital speech laws, to audit AI systems for bias, to design more effective legal remedies, and even model the overall health of a country's digital democracy. This is all about bringing a new level of rigor and clarity to some really complex and messy areas. And that brings us to our final section, a potential trillion-dollar shockwave. Because, when you introduce this level of efficiency and clarity into government and big business, the economic impact could be, well, enormous. Yeah, As the source material makes very clear, this is so much more than an academic exercise. The argument is that this could fundamentally reshape our economy by unlocking huge productivity gains that we just couldn't get to before. The headline number projected by the analysis is, well, it's just staggering. $5.3 trillion. So, what is that number? It's the potential annual global economic gain by the year 2035, and it's driven by these massive productivity and efficiency improvements, all unlocked because this structured approach to AI can systematically cut down on ambiguity and let us model things proactively on a massive scale. This chart here really puts it into perspective. Even with low adoption, we're looking at a 1.2% boost to global GDP. But with high adoption, that number jumps to over 5%. That is a massive economic shockwave, the kind of thing you see with major technological revolutions. And I mean, just listen to the weight of this statement. The analysis compares the impact of CRE for central banks to the invention of inflation targeting. That is not a small claim. That suggests this could be a fundamental new tool for managing economic stability on a national or even global scale. So that brings us to the final crucial question. We've gone from simple prompts to these complex cognitive architectures. We've seen how it can measure the unmeasurable and maybe even reshape our entire economy. So the question we're left with is this. Is building a custom mind the future of how we all work with artificial intelligence? Something to think about.